Engineers designing electronics are often faced with many types of thermal management challenges. In the next 3 minutes, we'll explore the benefits of a CAD-driven simulation tool to conduct multiple design studies for optimizing and validating your electronic systems and components. Let's first discuss some of the specific thermal challenges you may typically face during your product development process. Component layout, fan selection and placement, intake design and locations, ideal baffle locations, heatsink design, and optimization. All these items can be solved up front during the conceptual phase, giving you both quantitative and qualitative design insight before building a prototype. Let's take a look at some simulation results of a power supply design study. The goal of this project was to determine the viability of the baseline concept along with any modifications required to optimize overall thermal management, with specific focus on heatsink design and baffle placement. A quick assessment of the temperature profiles from the baseline analysis revealed that the processor chip exceeds 100 C, which is outside of the recommended maximum for that component and thus requires a design change to ensure product efficiency and extended life expectancy. However, let's first take a look at the flow performance to understand why the processor chip is operating at such an elevated temperature. This cross-section shows the velocity magnitude within the chassis, allowing for quick identification of flow distributions, areas of acceleration, and stagnant zones. Here you can see limited air movement across the top surface of the chip and much greater air speeds at the center line of the intake. Velocity vectors indicate the direction of air movement along with any recirculation regions, flow obstructions, and other typical causes of decreased fan performance. Adding a heatsink to the processor chip would take advantage of the natural flow patterns within the enclosure, reduce flow expansion near the chip, and increase the surface area for heat removal. ISO surfaces within CF Design allow you to easily locate and visualize local hot and cold spots within the chassis, along with areas starved for flow, all of which can be used to make informed design modifications required to improve performance. Particle traces are another great way to assess the air movement within the design, either at a system level or more focused to one specific area of interest. These traces indicate that the majority of the flow exiting these front boards short circuits through the components downstream. This short circuit, along with the elevated air temperature due to heat removal from the front boards, will increase the operating temperatures of the downstream components and reduce their overall efficiency. A simple and inexpensive solution would be to include a flow diverter downstream of the front boards and include an additional ambient intake for the downstream components. Let's now take a look at the performance gains associated with the two design modifications deemed necessary from the baseline analysis. This animation reveals that both the pin fin and extruded heat sinks have a substantial impact on reducing the processor chip temperature. The addition of the sink also eliminates the flow recirculation in that area of the chassis, resulting in less back pressure on the fans. Since both concepts are viable solutions for improving thermal management, heat sink cost and manufacturability would be the determining factors for final selection. Adding a flow diverter downstream of the front boards was found to reduce these component temperatures by 5 degrees through redirecting the hot air around these components, thus improving the efficiency and life expectancy of these devices. Companies such as Motorola, Canon, and BAE Systems have changed their validation methods and now incorporate CF Design simulation software upfront in their design process to help diagnose and solve thermal issues before building prototypes. So take the next step and learn if CF Design is a fit for you.